take out your note package to the section that says equivalent expressions. And two expressions are equivalent if, when they're simplified, mean that you've put all the like terms together, they end up being exactly the same. So if we simplify 4x minus 6 plus 6 minus 2, would you agree that the 4x and the x are like terms? And the 6 and the minus 2 are like terms. So 4x minus x leaves you with 3x, and 6 minus 2 leaves you with 4. They're exactly the same. So we're in the section that says equivalent expressions. It's near the back because we're almost done the book. Getting closer. I didn't. No, I said to stay here. Did she just go?
Yeah.
I guess she went. She was doing her test that she missed, and I said she should write it here. Okay, I will be right back.
Okay.
Okay. Logan, tell me one that you came up with. Okay, we'll wait a little bit then. I'm going to ask for one from everybody, so. Okay, Logan, what'd you get?
X plus 2x minus 5 minus 4.
X plus 2x minus 5 minus 4. Okay. Jacoby. You still going? Okay, I'll come back to you. Luke. Carly. Duncan.
I had 5x minus 2x and then 9 minus 18.
5x minus 2x, perfect. And then plus 9 minus 18. Perfect. Cherish. What's one that you came up with? Not yet. Aiden? 3x plus x minus 5 minus 3. Now at this point, you'd have 4 x's. Does that make sense? 3x plus x would get you 4 x's. So you could add another minus x here to make it 3 x's. And with a minus 5 and minus 3, where are you at? Minus 8. So to get to minus 9, you have to take another 1 away. Caden. Perfect. And Cherian? Okay. I'm coming back. I'll come back. So now back to Jacoby. Perfect. And then plus 12, take away 3, that'll get you to plus 9. But if we go the same thing and just change the signs on these ones, if you have minus 12 and then add 3, that'll take you to negative 9. Luke. Yeah, right here is what it needs to be equivalent to this. We'll wait. Sharon, you got one yet? Okay, keep thinking. It's coming back to you. Luke? Eight x minus 5x. Good. All right, same thing. If I did 11 minus 2, I get to plus 9. So, but if you do the same thing we did last time, if we just change the signs here to minus 11 and plus 2, you get to minus 9. All right, Carly? You don't have the whole thing yet? Well, we'll want to start with the x's. We're going to do part of it, and then we can help you with the rest of it. Okay? Do you have the x's yet? Okay, so what do you have for your x's? X plus x squared. Well, we'd write it as 2x, because if it's x and x squared, they're not like terms. But if we write x plus 2x, perfect, that'll make 3x. And then for our numbers, you need to have, technically, nobody thought of this, but you could just write minus 9. Because it would work, right? You wouldn't have to overthink it. That's still equivalent. You can make it more complicated if you want to. But as long as it's different than one of the ones that we have. Cherish, do you have one? Anybody think about doing x plus x plus x? That would make 3x. And then you could just go minus 9 to make it work. That would be pretty straightforward. So there's lots of possibilities here for ones that are equivalent. Okay, here's your next one. You need it to equal x squared minus 4. Caden, what do you have? Negative 2x squareds, maybe? Because there's no x's in here. So we can't have, well, we could if they canceled each other out, but negative 2x squareds. What would you have to add to that to get an x squared? Well, they have to be, remember that in order for things to be like terms, they have to have the same variable and the same exponent. So you're at minus 2 of them. You want to get to plus 1. You're going to need to add how many? How many x squareds would you have to add if you're at minus 2? You'd have to add a certain amount to get to plus 1. If you add 2, you'd be back at 0. If you add 1, you'd be at negative 1. You're at negative 2. Here's negative 1, here's negative 2. This is where you're at. You want to get to here. Yes. Plus 3x squareds. And then we need something to equal the minus 4. What did you have for that? Negative 2. And another negative 2. Perfect. There's 1. Aiden. All right, well, tell me a way that you could get x squared with 2 like terms. Tell me how you would get the number 1 adding or subtracting 2 numbers. How could you get the number 1 adding or subtracting 2 numbers? 2 minus 1. So a way that you could get 1x squared would be 2x squareds minus 1x squared. So the number in front, you could just think of regular adding and subtracting. And as long as you know what like terms are, that the variables are the same and the exponents are the same, then that would match up. Now we want to get minus 4. Aiden, what's a way that you could get minus 4? Minus 4. Minus 4 on your number line is right there. You could, but I want 2 numbers that give you minus 4. Adding or subtracting. You need to end here at minus 4. Pick a number, start. 8. So if you started 1, 2, 3, 4, 5, 6, 7, 8, if you started here and you wanted to get to minus 4, what would you have to do? So we're going to go plus 8. Obviously, going back, you're going to need to subtract. How many would you need to subtract so that you ended at negative 4? Perfect. All right, Carly. Oh. 1x squared maybe, because we don't have any x's here. So if we want to work with like terms, we want to have 1x squared plus 1x squared. So now you would be at 2x squared. And we want to end at 1x squared, so we do one more. Because here we did 1 plus 1, which is 2. Perfect. We want to end at 1. So if you're at 2, right, this is where you're at right now, and you want to end here, what would you have to do? Minus 1. So we'd minus 1x squared. Perfect. So 1x squared plus 1x squared gives us 2x squared. Minus an x squared gets us back to x squared. Now we have to do the minus 4. Can you give me two numbers that will end at minus 4 with adding or subtracting? Negative 5. Perfect. So now you're right here at negative 5. And you need to get to negative 4. Okay, we're going to the right though. We're going to be adding. Perfect. Duncan.
I don't have one yet.
I'll come back to you. Luke. 3x squared minus 2x squared. Perfect. That will get you to 1x squared. Excellent. Jacoby. You don't have one yet. Logan. Back to Duncan. You've got to hurry. There's only a loop of 3 of you, so it's coming quick. Duncan. Back to you. You making a complicated one? Oh yeah, Cherian. Okay, we want to get x squareds to be 1x squared. In the end here I'll move these ones down. Whoa, not that one down. You want to get an x squared with two like terms. If I add x plus x, those are like terms, I'll get 2x, but I will not get x squared. So the only way to get an x squared is if you start with x squareds. So what do you want to start with? Okay, add another one. So now you're at 2x squareds. How would you get back to 1x squared? Take one away. Awesome. Now to get minus 4. Two numbers to get to minus 4, adding or subtracting. Okay, so what number are you going to start with? 2. So you're at 2 on your number line, which is right here. And you need to get back to minus 4. How many would you have to subtract? Careful, count it out. 1, 2, 3, 4, 5, 6. Duncan.
I have 4x squared.
Okay.
Minus 2x squared.
4x squared minus 2x squared, perfect.
Minus 1x squared.
Minus 1x squared.
And then 10 minus 14.
Plus 10 minus 14. Does that work out? We've got 4 minus 2 will give us 2x squareds, minus another x squared will give us 1x squared. And then 10 minus 14 will be negative 4. Jacoby. 5x squared minus 4x squared is perfect. That'll give us 1x squared. Oh, so close. If I'm at -2, I'm right here. If I take away 6, I'll go too far. But if you started at +2 and took away 6, it would work out perfect. And Logan.
4x squared minus 3x squared plus 11 minus 18.
This will give us 1x squared. And if I'm at 11 and I go back 15, yes, that will end perfectly at -4. Excellent. Explain if 2x is equal to x squared. Can I get you to make 40 copies of this back to back and stapled?
48.
40. 40. Yeah. Are these equal to each other? No. They are not like terms. Can you pick a number for x which really shows they're not equal to each other? If x equals 2, this one's 2 times 2, which is 4, and this one's 2 squared, which is 4. So you might think they're equal if you pick x equals 2.
Because you're
Can-
timesing one, but then you're squaring.
Right. Can you pick another number other than 2, though, that really shows? If you pick 8, then 2x is the same as 2 times 8, which is 16, and x squared is the same as 8 squared, which is 64. Then they would for sure not be the same. Is negative bracket x minus 3 equivalent to 3 minus x? You're saying yes. And how did you come up with yes?
Because using the distributive property.
Okay, so Duncan's saying that we have a thing outside of brackets we have to distribute. And that will give me negative x, and negative times a negative, positive 3. Is that the same as 3 minus x, negative x plus 3? Question mark, is this the same as 3 minus x? Well, this is getting into an idea of whether adding and subtracting does the order matter. For example, 2 plus 7, 9. If I do 7 plus 2, 9. For adding, doesn't matter if I switch it around. 10 plus 3, 13. 3 plus 10, 13. Can you think of any one where you're adding where if you change the numbers around you get a different answer? Like 5 plus 7 is 12. 7 plus 5 is 12. Is there any way that where I switch them that it makes a difference? It's always the same. So if I take this and switch it and put 3 plus a minus x or 3 minus x, they are the same.